for this video, we're going to look at topic 2, lesson 1, example 5. So the function of g, and we're going to see how to write an equation of a transformed function. So just kind of like that last example. The function g is a translation of the parent function f, 1 unit left and 3 units up. What is the equation of g? Write the quadratic equation in vertex form and in the form f of x equals ax squared plus bx plus c. So I'm going to start here and I'm going to look. I know that my new vertex here, we've moved up 3 over 1. So my vertex is -1, 3. So then we have a sign change here. Like I put another ax plus 1, because again, to get this -1, this had to be a positive 1, plus 3. Okay, now we need to find a. So what I'm going to do is I'm going to come back to my graph. Let me erase. Oh, that's not an eraser. That's a nice green. And I'm going to look for a point on my graph where we have two integers for x and y. And here my x is 0 and my y is 4. What I'm going to do with this is this is going to take the place of x, and this is going to substitute in for f of x. So I'm going to say 4 equals a. We don't know what a is. That's what we're trying to find. My x in this case is 0 plus 1 plus 3. All right, so 4 is equal to a. 0 plus 1 is 0. 0 plus 1 is 1. 1 squared is 1. So that's going to be 1 times a, or a, plus 3. Now I'm going to get my constants to one side of the equation and my linear variable to the right. And this only works if your a has no powers. Technically it's a power 1, but no visible powers above it. We get 1 equals a. Substituting that back in, if this is a 1, it's not doing anything. You multiply 1 and it's itself, so I'm not going to include the 1 when I write my final vertex equation. Now I want to do standard form, and to do standard form, you're going to need that ax squared plus bx, it looks more like a t, sorry, bx plus c. So what this really means is that you're multiplying the expression by itself. You're multiplying x plus 1 times x plus 1. So when we expand this out, we're doing x plus 1 times x plus 1. And we need to expand it so that we can get that, the formula into ax, the standard formula, ax squared plus bx plus c. Okay, using FOIL, I get x squared plus 2x plus 1 plus 3. So I basically did a couple of steps in one there, but you're going to use FOIL to get this. And then x squared plus 2x plus 4 will be our standard form. And just off to the side, just in case you didn't see the FOIL or see how I got x squared plus 2x, I'll show you. So we're going to multiply the first ones. So that's x squared. Then the outer, O, that's x. Then the inner, which is going to be x again. And then the last, which is going to be 1. Combining like terms, we get x squared plus 2x plus 1. And that is how I got this guy right here. So this right here is now considered the standard form. And we will go back to this so that we can see their solution. So again, here they have it. They too, they have the f of x plus 1, showing that this is the transformation to the inside parent function. This is a transformation to the full parent function. Then they looked at 0, 4, and they found that a is equal to 1, just like we did. Substituting 1 back in, they went from their vertex form here to their standard form here. And so the vertex form is x plus 1 squared plus 3. And in the form of ax squared plus bx plus c, or standard form, the equation is x squared plus 2x plus 4. All right, let's see their study tips. You can confirm your equation by picking a point that is on the graph and checking to make sure it satisfies your equation. That's a really good study tip. So in this try, you're going to do what is the equation of j. Write the equation in vertex form and in the y equals ax squared plus bx plus c form. Let j be a quadratic function whose graph is a translation 2 units to the right and 5 units down of the graph of f. F is going to be your x squared graph. So again, your vertex, that center, that minimum point, is going to go 2 units to the right. So that's 2, 5 units down. So it's going to be -5 for your point. So in other words, if this was your original graph, you're moving over 2 units and 5 units down. And this will be your new kind of vertex point. So you're looking at 2, -5 for your vertex. And let j be a quadratic function whose graph is reflected. So now we're looking at that -a of the graph f in the x-axis, followed by a translation down 1 unit. So we're looking at a reflection. And then we're also looking at it, this point right here, moving down 1 unit. So we're looking at a vertex of 0, -1, and we're looking at a reflection. So again, my arrows are pointing in the negative infinity, which means that we're looking at a negative a. So again, if you have any questions or comments, please get a hold of me as soon as possible so I could clear up any confusion, and we will be talking to you guys later.